All right, let's talk some housekeeping stuff. So remember, today is Thursday. Tomorrow's a virtual day, then Memorial Day weekend. Then we have school on Tuesday, Wednesday, Thursday. So Tuesday's the first, Wednesday's the second, Thursday, June 3rd, is your test. Mr. DeWar and I decided that your final day for all things to be turned in that we will guarantee that we will give you credit for it is a lot later than, I'll be honest, a little later than I'd feel comfortable with, but I'm going to do it. June 3rd, which is the day of your test at 8 a.m. Now, just for the record, I'm pretty sure we have ELT on Wednesday that you turn in your iPads.
Tuesday.
I think it's Wednesday.
I've been told by 3 other teachers Tuesday.
Okay, I will look. Okay.
It's June 1st, is that Tuesday?
June 1st. Is it June 1st? June 1st. Okay, so you will not have your iPads for 2 days. So if that is your plan, then that might be a slight issue. Okay, so be aware of that. So plan in advance. You have a 4-day weekend, or 3-day weekend with a virtual day. But that's kind of our deadline, firm deadline there. So that's kind of the housekeeping stuff that I want to take care of. Now, if you are watching this video, we just watched a Bill Nye intro, and it's linked in Canvas under the slides presentation that you should watch on your own. Okay, it's a quick 4-minute video about climate change. For the rest of us, and where we're picking up, is we are going to kind of introduce and talk about this. So when we talk about climate change, back in the 1950s, there was a scientist by the name of Dave Keeling who started looking at carbon dioxide emissions in 2 locations, Antarctica on the South Pole and in Hawaii. And if we look at this graph, what this is these are carbon dioxide levels when he started recording them in January of 1979. Okay, this is where it is. This is concentration in parts per million of carbon dioxide. Now, why do we care about carbon dioxide? Carbon dioxide is one of the major greenhouse gas contributors that we have. So this is the equator, this is the South Pole, this is the North Pole, this is the Antarctic, and this is Hawaii. So if you look, there's fluctuations, there's more fluctuations in the North Pole, in the northern region, than there is the southern region. And if you look over here on this graph, we definitely have these fluctuations, these highs and these lows. So sometimes people say, yeah, but it always fluctuates, it's always changing. You're right, it does. Every season it changes. So for example, here in Wisconsin, in January, our carbon dioxide levels are going to be higher than they are in July. Why? Why is the amount of CO2 in our atmosphere higher in Wisconsin in January than it is in July?
Because we're heating stuff.
What's that? Because we're
heating stuff.
Because we're running furnaces, we're heating our homes, partially, yeah. What else? What's that?
Trees.
What about trees? I can't hear you.
They can take the carbon dioxide.
Through the process of photosynthesis, right? Most of our trees, like there's a few pine trees that aren't photosynthesizing, right? So they're not taking in the carbon dioxide, they're not removing it from the atmosphere. So we get these spikes, and we see that in the Northern Hemisphere, and that's what causes these ups and downs. But if we look at overall trends from 1980 through to like 2010, yeah, there's ups and downs, and that's summer versus winter. But if you look at the overall trend is going up. Now, what happens along the way? We have more of these stations. These are more data points at different latitudes and latitudes. So we get a better model, okay? So that is like where we are like in like 2010-ish, 2016 I think is where. And now what they can do is instead of just going through and these are direct observations that they can get from these weather stations. But then what they can do is they can start going backwards in time and they can look at carbon dioxide levels in history. And you say, well, how do they do that? They do use something called an ice core. You may have heard that term before, but basically they take a plug, like if you were to just drill a hole, like an ice fishing hole, but not drill out the center, but you only drilled like around the edge and you pull that slug or that plug up, you now have a chunk of ice, like an ice cube. And in that ice, the layers of ice in Antarctica, the South Pole, each kind of year has a layer in it. And we can go back in time and we can look at how much carbon dioxide was trapped in that ice back in time. That's a different observation. Now these are some extrapolations for way back, so before Common Era or BC is where we can go. So you could say, well, they've always changed. You're right, they always change, but this is where the estimated is, but then this is when they started measuring and we have greatly increased amount of carbon dioxide. So why do we care about carbon dioxide? Major greenhouse gas, which is responsible for a lot of the changes. So this is from NOAA, which is the National Oceanic, and Atmospheric Administration, okay? So this is a scientific group that collects ocean data, and they're really concerned about ocean because with melting of ice, 4 miles by 4 miles by 4 miles, the ocean levels will increase. So again, this is that carbon dioxide, parts per million of carbon dioxide. So even though you could say, well, the oceans have only risen 0.4 degrees, that's not a lot, it's significant. And by increasing it 0.4 degrees has caused to some pretty significant changes. So this is talking about temperature anomalies. So this is like average, zero, no anomalies. This would be a warmer than average like year. This would be a colder than average year. So if we go back to like 1880s, we definitely get some that are below average and we get some above average, but if we look at overall trends, we see that we have an anomaly that tends to be increasing as we go on with time. So, what are the causes of that? What are some signs that are saying that this is going? One thing that they talk about in the Bill Nye video is he talked about 97% of climate scientists agree that humans are the cause of climate change or global warming. And you can say, but there's other scientists that don't. You're right, there are some other scientists that don't. And you can say 100% of the climate scientists, he said 97%, which is not 100%. I know it's not 100%, but it's pretty darn close. And you can say, but what about? Okay, and the idea is you want to make sure that when we start talking about what does the experts say, that you're talking about the experts. An expert in one field might not be an expert in another field. Okay, so we're going to start talking about like doctors. Well, doctors know a lot about COVID, right? Doctors know a lot about COVID. Probably a pretty safe assumption to do. So we should go then talk to Dr. Rather and Dr. Bohm about COVID, right? They're doctors. They have the doctor title in front of their name. They are both doctors for the record. Well, why don't we go talk to them about medical COVID stuff? Because is their doctoral degree in medicine? No, it's in education. Okay? Just like you probably don't go to a medical doctor and say, hey, what do you think about education and how do you think it best is for students and learning, right? So the idea that I'm trying to make is when you want to know something about a particular subject, consult the people who are experts in that field. Don't just look at flashy titles. Make sure that flashy title matches the field that you're looking at, right? So when we talk about climate change, I think going to the climate scientist is a good start, okay? So then what today's gonna do is you're gonna spend some time digging through I think it's NOAA again, some websites. And on these websites, you are gonna look for they call it the 10 signs of a warming world. So the worksheet you picked up on the way in has this, and there's some background information. Basically, you want to kind of in your mind be asking yourself a question that's going to kind of drive some of the research you're looking at. Now, what we're trying to pack into like a day or a half day of research, because you have about half a class period of research probably left, is something that we could easily spend like a month talking about in all. You know, Mr. DeGrand, one of the other biology teachers, He was a meteorologist before he went into becoming a science teacher. He said he developed a course in his other school that they spent like 2 months talking about climate change. He said we could easily develop an entire semester's work. So what we're trying to like shove in to hit some major points of today is really just skimming the surface. So when you're going through this, you kind of want to ask yourself a driving question, and you want to figure out like what causes it, what effects it has. You should kind of have some idea of what you're going to use to kind of push your research or kind of what you're looking for. So there's 10 different signs, and these 10 different signs on these websites are all linked up here. So when you want to say like, what are the 10, there they are across the top, and what effect does the Arctic sea ice have on a warming world? Or what is the evidence that Arctic sea ice shows us about the warming world? And they show satellite images, they look at data trends, and all of these things are like clickable, and never mind, you can't click on that one. And there's more information, there's some videos if you wanted to watch. Okay, so there's 10 signs of a warming world, and you're supposed to go through and look at those 10. Then on the back side of that worksheet, they talk about 3 variables. Now there are lots of variables that you can click on. It's asking you to choose 3. There's 9 down here. And when you select it, so right by default, these first 3 are the 3 that are they're on the dashboard. But what you can do is you can say, I want to look at how temperature, Arctic sea ice, and snow, is there any connection or correlation between those? So here's the 3 different things. You click on the learn more, and you are to get some information about the spring snow cover, and you can learn more. The last thing on that worksheet is it talks, and we're modifying this slightly from the information. It talks about conclusion. You're going to write a summary of what you found today. It does say something along the lines of a 4-paragraph essay. We're not going to say it's a 4-paragraph essay. Okay, all paragraph is sufficient. But the idea is you're supposed to kind of go through and summarize what you've learned from this activity, about the signs, about some of the effects of climate change. Okay. Once you're done with that, Canvas submission, take a picture of the 2 sides of your document. I would encourage you, actually, there's 2 options. We have paper copies. If you want a paper copy, they're there, or on that front cart, and most of you grabbed them. The Google Doc might actually be, it's up to you, a better option, because there's not a whole lot of space for you to like fill in spots for those. So it's up to you if you want to do a paper copy. There it is. But I think it might be slightly better if you typed it on Google, just because there might be more space. I suggested that first hour or second period. I don't know how many actually did it as Google Doc. I think most people still went to the paper, which is fine.
At least grab one, yeah.
You know, which is fine. Just realize that you might have to write a little smaller in those boxes just because there's a fair amount of information in there. So there's that. And then at some point along the way, we'll put out the guided notes, because between this and Section 4 guided notes, the last guided notes of the school year on human impact on the ecosystem, that needs to be done by tomorrow. So between today's class and tomorrow's virtual day, you need to finish this activity and Section 4 guided notes. On Tuesday, we'll talk about human impact and what that means. On Wednesday, we'll spend some time reviewing for your test on Thursday. And then we're done for the year, okay? So that's what you're working on right now. If you have questions, please let us know.